టైం దొరకదు, మాట్లాడే కూడా దొరకదు. 1 hour 1 hour లో క్రియేట్ చేసి మాట్లాడాలంటే ఇట్స్ నాట్ ఎ జోక్ మేడం. ఎంత ఫ్లూయెన్స్ మేడం, అది ఎంత
And a warm welcome today's session, Dr. Babu Nageshwar Rao.
Thank you, sir.
Sir,
Namaskar.
1 minute, the Ishwar. I'm giving the co-host. Yes. Babu Nageshwar Rao.
Yes, sir. Good morning.
Okay.
Good morning.
Good evening. Namaste.
Namaste, sir. Namaste to all.
Long back.
Yes, sir.
A warm welcome to today's session. The faculty development program sponsored by AICT New Delhi and jointly organizing by JNT University Anantapuram, JNTA Pharmacy College, OTPRI Anantapuram, all the eminent the faculty members across the India attending the session. And today eminent the speaker and intellectual Dr. Babu Nageshwar Rao, and he is from the researcher, postdoctoral fellowship researcher, University of and USA. With this, Amini can introduce the today speaker to the our co-faculty members.
Yes, sir. Sir, good afternoon, ladies and gentlemen. Today we are pleased to welcome Dr. K. Babu Nageshwar Rao Garu, sir, a very special person, special guest from USA. Sir is a postdoctoral research fellow from University of Cincinnati, Division of Cardiovascular Health and Disease, Department of Internal Medicine from USA. Sir has completed his B.Pharm from Chalapati Institute of Pharmaceutical Sciences, Guntur, and M.Pharm from the IIT Banaras Hindu University, Department of Pharmaceutical Engineering from Varanasi, and PhD from the CSID CDRI Pharmacological Division, Lucknow. Sir has a teaching experience in the Biomedical Research Capstone course from University of Cincinnati, and Sir has got 3 awards. Sir has 9 review publications from different journals. Sir is a member of an American Health Association from USA, and a member of an Endocrine Society from USA, and member of a National Postdoctoral Association from USA, and member of an American Society for Nutrition in USA. Sir has 2 books publications. Sir is very much interested in research areas like sudden cardiac death, myocardial infarction, cardiovascular diseases, and endocrinology, neurocardiology, lifestyle-related metabolic diseases, etc. And with this, I heartily welcome you, sir, for this session. Dr. K. Babu Nageshwar Rao Garu, sir, from behalf of our principal, sir, and administration, and all faculty members, sir, we heartily welcome you for this session, sir.
Good morning from United States. Thank you, Emanigari, for such an introduction. And thank you, sir. Thank you, Gopinath, sir. Like today, my topic of discussion is systems pharmacology in drug discovery and development. It was, I think, surprising that my previous speaker was also speaking about nature as a cure. And my topic introduces everyone as an extension of the previous topic, actually. With that, so this topic goes in understanding my journey in understanding research and science, a pragmatic change from reductionist thoughts to systems approaches. So in connection with the current topic, like the pharmacy in present and the future challenges, so my topic takes you from reductionist approach, which is the present challenge, and takes you to the systems approach, where it will come towards future challenges in pharmacy. Before going to the topic, I want to acknowledge the sponsor, Faculty Development Cell, AICTE, New Delhi, organizers of Jntua, Anantapur, Oil Technological Pharmaceutical Research Institute, Anantapuram, and organizing committee, especially my teacher, Professor Gopinath sir. I was a student at Chalapti Institute of Pharmaceutical Sciences, Guntur, when I was studying my bachelor's there. And I remember those days where I was learning pharmacognosy and chemistry of natural products from him. And that is an inspiration behind this today's talk. So there lies no conflict of interest in this topic. So no University of Cincinnati is not at all involved in this issue. Coming to the topic, this is what every pharmacist, when they start their career in Bachelor of Pharmacy, they see this diagram. I hope so that this doesn't requires much more of introduction, the traditional classical drug discovery process. And this career took me mostly to the preclinical development where I work with pharmacology. This is what I wanted to emphasize in the slide. And during bachelor's, two things mostly attracted me, fascinated me when I was seeing the pharmacology textbooks of Rangendale. One thing is how drugs work. Like there used to be cartoons like this in Rangendale, like how drugs work. This was the fascinating thing. And what are drug targets? This is the second fascinating things. What are different types? What drug suits to which drug type? And these are the two aspects, as I mentioned. And with this fascinating aspects of pharmacology, I took a master's in pharmacology in IIT Benares in the University of Varanasi. So master's is something like a deepening scientific attitude in my career. Whole master's, when I was doing my pharmacology there in specialization, the main important aspect was the fascinating brain. Brain was which fascinated me a lot because different parts of brain, how it connects to different parts of peripheral body, different lobes and their activities. I studied a lot there and I tried to make sense in a logical perception. And this was one of the fascinating thing that was taught in masters is the binge intoxication, withdrawal effects of cocaine, and how those different pathways interact in brain. So this took me more interest in understanding brain and the connections in different parts of the brain. And one more thing is the rewarding and anti-rewarding systems, how they affect our growth, the brain growth, and how it impacts the peripheral health. So he's Professor Sairam Krishnamurthy, who taught all these aspects in pharmacology. And he was the one who brought a lot of interest in me in especially CNS pharmacology, because most of the CNS pharmacology was taught by him. But time took to me into a different lab, Professor Sanjay Singh, ex-head of pharmacology there. And I worked in a topic called hepatic encephalopathy, which combines the peripheral health with the central health by ammonia intoxication. So my master's thesis was involved in studying the protective effects of eugenol in hepatic encephalopathy. So coming next to the research, actually after the thesis, we don't know much about the research, as I say. We just did some topic there, we got a thesis, but it was at the starting stages of understanding what the research is. Fortunately, with my GATE rank, I gave an interview at CSR CDRI, and that took me to my PhD path, which is the core of research, which takes me into the next stage. So the first primary important project which I worked in my PhD is Thunder, which is abbreviated said as Towards Holistic Understanding of Complex Disease, Unraveling the Threats Behind the Disease. So this project mainly involves understanding insulin resistance and studying different tissues in insulin resistance in relation with animal models using high-fat diet, high fructose diet. I got fortunately an opportunity to work with Dr. Madhu Dixit, who was the former director of CSR CDRI at the time, and now she is now in national chair in THISTI. So my topic goes in understanding the role of redox mediators in different tissues there, which is liver, vasculature, skeletal muscle, adipose tissue. I was working in a collaborative group where different people are studying different tissues there. And my peer was interested to understand how redox modulators plays an important role in different tissues. So this question took me what actually systems is, because when we give high-fat diet, for example, to an animal, what happens is there is pathology which has been generated in different tissues. It means that different tissues has to speak together. It's not that one tissue participates separately. That's the question that started intriguing in my mind. So this is where also, this is the part where I started learning the research methodology, how to write papers in international perspective, how to give comments, how to get critical understanding of how a research paper to be. So these are some of my publications. And after 5 years of many things happening in life, I got my PhD there. And this is CSR CDRI snapshot there, which is the new campus of Central Drug Research Institute in Lucknow. But coming back to my previous point, how systems talk together, how different tissues talk together, how do they connect? This is what, as I told, it intrigued me. And then when I was looking back to more literature, fascinatingly, there was a review which was published at that time, which is a cross-talk between different tissues, where the future drug research lies. So this is a clinical perception of insulin resistance, how different tissues work together during insulin sensitivity. Like when insulin is being released after a person takes a meal, insulin acts on different tissues in insulin sensitive conditions. What happens to those tissues? And in insulin resistant states, what happens to those tissues? And you can see that these are three different peripheral organs: liver, pancreas, skeletal muscle. So they release different pathological mediators, which plays an important role during insulin resistance. So you can, it's obviously understanding that it's a complex interplay of different mediators. But how do they speak? Do we have sufficient technologies to study in a wet lab these cross connections? That's what intrigued me. And that's where my next topic goes in systems pharmacology. Before going into systems pharmacology, the principles underlying the systems pharmacology is one important thing, that is systems biology. Systems biology is an application of systems principles to biology. And systems biology includes physiology, cell biology, molecular biology, and biochemistry. It's a combination of many different things. Systems biology is broad biology to engineering, to computer engineering, because you use computers to validate or to model things, what happens in biology, to understand things, so that you can take those understandings and go to experimentations. As I told, systems behavior is a combination of experiments in wet lab and computation models. The computation models uses computers, which means the simulations, which shows how interaction between different components give rise to functional capabilities that the individual components do not have. So what's the difference between a traditional experiment in a pharmacology and a systems experiment? Like in common scientific workflow, there is a hypothesis and we perform an experiment based on hypothesis and we get some results, and that becomes a current understanding. And depending upon current understanding, there goes an hypothesis once again. It's a circular path which takes up. But how systems biology is different. Systems biology, here, the current understanding goes with quantitative computational models. So we have hypothesis, we perform experiments, basing upon that we get some current understanding, and this current understanding goes to quantitative computational models, and depending upon models we get some results back, which becomes the current understanding and which generates the hypothesis and those circles. So these computational models is an additional part in systems biology. So he's a famous systems scientist from MIT. He was mentioning, this intrigued me at the time too. Systems thinking is a discipline for seeing wholes as a holistic perception. It's a framework for seeing interrelationships rather than things, for seeing patterns of change rather than static snapshots. The whole reductionist approach of pharmacology, which we generally do in lab, is what is called a snapshot. It's a static snapshot, which is an endpoint research. We do add some drug, we see some effects, we take some tissues, do some activities, and that's it. That's an endpoint. But human biology doesn't goes in that way. It's a combination of mind and the body, which continuously work together. And that's where the systems approaches comes, because it's a combination of interactions that goes every day. So Coming to the difference between the mode of action of classical view of drug action and the systems view of drug action. So in the classical view, a drug acts on a primary target and a drug also has an off target. The primary target has a therapeutic effect. The off target has a side effect. This is how we see in pharmacology, if you guys agree with me. But in systems pharmacology, the view is different. The drug has a primary target and the drug has other targets too. These primary targets and the other targets all interact together, which makes sense. And these interactions leads to therapeutic effect. These interactions also leads to side effects. And this depends upon each person because the interaction depends upon the genetics of each person, which takes you to pharmacogenomics and individualized and personalized drug approaches. So basic advantages of systems pharmacology are systems pharmacology, as you can see, that it plays an important role. As I was showing in my first slide of classical understanding of drug discovery, it helps in every step of drug discovery, starting from preclinical to systems pharmacology of clinical. At every step, you can see here, modeling helps you in at every step. Like if you translate to clinical, it also helps you in toxicology through PKPD. My colleagues, I think Ramakrishna, he'll be giving a talk on PKPD and PKPB next, I think. So he will explain you about those things, how the modeling helps out and how it you can take a preclinical data or a clinical data, rate constants, and you can how to model it in a form of software. So this is how it goes. And interaction between vertical and horizontal aspects. If you see the vertical integration, that is the purified cells, purified components, that is the drugs or the new chemical entities, cells, organs, animals, patients, populations. So this is the hierarchy of drug discovery as it happens. It happens at different levels. And if it is horizontal integration, it is target in cells, cellular networks, and molecular networks. So as system, each organ system, for example, of liver, the liver has different tissues, different cells. Different cells, each cell has a network and different cells has different networks. And these cells speak together in liver itself. So that's it, the liver is a system. And liver speaks with gut, which is a gastric intestinal tract. And that is a system by itself, which has different networks. So my takeover point is there are different networks at different points of time and different spaces in the body. And these networks connect through different systems. And which is where the modeling is very important because we don't have such techniques to do it in the wet lab. This is an extension of what I explained you now. If you take an herbal compound having many different components, so there are different components, each drug will interact with the target, different components interact with different targets at micro level. At mesoscopic level, these different targets may come up from different targets in a pathway. So obviously different components may work with different targets in different pathways and adding up and affect in macro levels, which is at the cellular level. And these tissues also speak together. If you have a positive effect in a tissue, the tissue says to other tissue, hey, things are going good at me. So the other tissue also starts feeling healing. That's how the systems approaches are. And this is called organ or holistic level. So coming to areas in which systems pharmacology, which is quantity system pharmacologist model, will impact drug discovery at each level. At network biology level, at choosing the right pathway, pharmacology choosing the right target, preclinical PKPD choosing the right molecule, clinical pharmacology choosing the right dose, pharmacometrics choosing the right patients. So these are the basic steps. There are different aspects because there are different institutes, there are different softwares, many things, many limitations, many algorithms. I will not go into that because I'm also not an expert in that area. But what I understand from systems pharmacology persona, there are three different steps that are involved. One is understanding the ADME for the screening of bioactive components of herbs-based phytopharmaceuticals. As you understand that phytopharmaceuticals having different components. So how to understand the ADME parameters? It's very difficult to understand by doing an experiment of that many components. It takes a lot of cost. So there are models that are developed, algorithms that are developed, based on which models are developed. And the primary one is the element model, where you take different physical parameters and the in vitro data of different components and do elemental models in this. And depending upon elemental model, there is a decision model and expertise model. And depending upon the understanding from these different models, you will come a conclusion to cross-validation and system decision. So this is what the next phase is. Next is the drug target identification. Okay, you have different components. What next? You need to have targets. That's where the drugs act. So how to understand the identification of different targets? By the way, you cannot also do this many components and this many targets. You can only validate them. So the drug target identification also includes different in silico approaches like system drug target identification technology. That's one. Weight balance similarity is another. PRED binding models, this is another. So these are different models that are being generated in computer simulation perspective to understand the different targets. So how to connect the first aspect with the second aspect is the third aspect, which is design process of the drug combination prediction approach. So you have drugs, as I mentioned, you have targets, and depending upon their interactions, you'll be getting Bayesian networks, the network of interactions between these different components. And depending upon the drug-drug interactions you see, drug-target interactions you see, you come up with different drug pairs which are likely. And this can lead to efficient refinement and development of new herbal components, multiple targets or multiple components of drugs, which takes you in a holistic perspective of different development of different formulas, herbal formulas. I didn't include in this slides, but there is one thing called reverse pharmacology. The people started in exo drug discovery. The pharmacological action has already been known in books like Charaka Samhita, Shushruta Samhita, coming from Ayurvedic approach. They take those in chemistry of natural products section. The effect was previously known, and they try to validate it. This is called as reverse pharmacology approach. So coming to the perspectives in network pharmacology, the next is I'll be presenting 1 or 2 case studies so that you guys can understand how the cases go there in research. And before that, network pharmacology, as I told, systems is very complex. So to curtail the aspects of systems, it's better to take a network pharmacology approach, because network can also happen in a cell, can also happen in single tissue itself. So our interest is to study a tissue rather than understanding first between tissues, which requires more complex modeling. So the networks pharmacology includes implication for therapies, which are these aspects: onset, offset targets, new drug target identification, drug screening and discovery, personalized medicine, and the approaches they use are genomics, epigenomics, transcriptomics, proteomics, metabolomics. So all omics approaches, which has been skeptical too because of their fishing nature. Sometimes we don't end up anywhere, but it is what it is. The system is such complex that we have to start at some point in modeling, and we have to validate the things. And this is what I'm explaining in the future systems pharmacology is all in future challenges of how the pharmacology and the drug mechanism of action goes, taking someone from reductionist approach to systems approach. Yeah, coming to the case study. So this speaks about a study that was published in Scientific Reports, drug target identification using network analysis, taking active components in cine decoction. Cine decoction is a decoction. By the way, most of these systems pharmacology approaches has been done with traditional Chinese medicine. It's a failure, I think, of Indian and the future research has to go in that way, because my previous speaker was also speaking in that. So I got excited to tell this, that people should start taking the natural components from Ayurvedic formulations and those and try to validate it. That's how the nature is. Because all these systems pharmacology approaches that I explained, I have to take it from Chinese herbal medicines rather than taking from Ayurvedic formulations or something in from Indian perspective. And Chinese has gone much more beyond, and they got different algorithms, different databases itself to understand how these complex mixtures work. Anyways, coming back to my first point, is this is the approach that they used in this in their paper. This approach is more or less, it combines with different papers that are published in this area, taking drug mining, from databases through text mining, in vivo compound similarity search, and taking different targets actually from molecular docking base, seeing the interactions between the drugs and databases through target component protein network. This is the target protein component network, the left side, and the drugs also interact with some of the metabolites. Rather than proteins, they also work with metabolites, which are chemical structures. And these metabolites are also part of resultant of proteins interacting with metabolites. So these metabolites interact with pathway proteins. So we try to take compound target protein network and try to simulate the interactions between compound protein pathway network, and you perform the network analysis, which speaks about the target protein and the pathway protein. Pathway protein is a protein which participates at a middle, but the target protein is a critical nodal protein. If you guys are new to this, I'll explain in the next slide what they are. But from network analysis, this target and pathway protein interacts, and they also try to interact with components, target protein, pathway protein, and metabolites. It's a huge understanding of different perspectives to see how different components work together. So this is an example of, this is a projection from Cytoscape 3, where after checking those through in silico softwares of different components. So these are the green color one shows about the target genes. This red colored circle one shows the active components in the CNAD caution. This many active components are there. So this is the best view of pictorial representation of how these different components is. So these are the hexagonal ones are the target genes found by text mining. The hexagonal green ones are the target genes found by the docking studies. And the yellow one is the target genes found by text mining and docking studies. As you can see that there are different interactions at different multiple levels, which needs a lot of validation once again. And this is the pathway and the metabolite analysis. These are the different pathways that they took. These are all published by if someone is really interested, they can go through these publications and they can go through the softwares and all, and they can open a new thing in a research. It's not a rocket science. I think it's easy, doable in an Indian perspective. And I'm happy if someone takes it in future. The pathway protein and a metabolite, this is the pathway for that. And as I told, this is the component and the pathway protein, and this is the this is the component and the target protein, and this is the pathway protein and the metabolite interaction, and checking the interaction between these pathways once again. So this is how such complex interactions and requires a lot of computational models. And by the end of this, what conclusion was from the study is the network included 130 nodes. I didn't explain, I'm sorry for that. The nodes is here. The node is a vertices, which the interactions are. So these are the components where the critical interactions happen. And the interactions are showed by lines, but the nodes are the critical points of the interactions. So depending upon how many nodes are, that many interactions are. So the network included 130 nodes and 375 edges, 48 components, which are the chemical entities, and the 25 target proteins, 44 pathway proteins. So in that paper, they tried to take what is the mechanistic of action of the herbal drug. That's what they tried to do. Because in traditional pharmacology, if you do it, you cannot do it, and you cannot show this many interactions. So my next case studies also goes in this way. Is the second one, the systems pharmacology dissection of the integrated treatment for cardiovascular. Since I'm in cardiovascular fascinates me, and gastrointestinal disorders by traditional Chinese medicine. And this is the approach, as I told, more or less, it is in a similar way, systems pharmacology approach framework. And this includes different aspects, as you can understand that they did. So in this paper, they took different aspects of the natural components here, in the heart protective and the cardiac, and the gut protective one, which are already established in literature, and try to validate those. So the specific aspect of this paper is that try to see the connection between the gastrointestinal and the heart pathways. So the three important pathways is calcium signaling pathway, CGMP, PKGP signaling pathway, and the vascular smooth muscle contraction pathway. These are the three pathways which the targets are found to interact both in the heart and both in the gastrointestinal. See how fascinating it is to see that how different tissues speak together, and how, if you give a herbal formulation, how the different components go to different tissues by different absorption, distribution, metabolism, and elimination capacities, and how they act in different tissues. So the target organ location map is one thing where the blue node represents the molecules, which are the chemical entities, and the colored circles represents the target nodes along with the organs in which the target is located. So you can see that these are the different targets. One is located in heart, whole blood, gastrointestinal. You can see that the targets are interacting also between different tissues. This is what I mentioned as the systems, because there are different targets in different systems which are cross-talking once again. And the cross-talking is through release of endocrine hormones once again, different tissues. Previously, we know that the endocrine system is mostly from the pituitary and the central nervous system, but now it's not the game. The game has started change in the way of bone is an endocrine organ, and adipose tissue is an endocrine organ, skeletal muscle is an endocrine organ. Different tissues, different peripheral organs are all endocrine organs now. So they speak with different organs through the language of hormones and signaling. So the third and the final case study is the systems pharmacology. This is for functional dyspepsia, and it also goes in the same way. I just wanted to present it. It also goes in the same way. I'm not going into the more details of this. And this is one important thing which I was speaking about. There's a published in Journal of Chemoinformatics about a database that they, in the Department of Bioinformatics, I didn't remember the university where it is, from China, but it is a Department of Bioinformatics. They created a systems biology database itself having different algorithms, which mentions, like, it goes like this. So this is the lab of systems pharmacology, and you can keep a pre-select filter here as a herb name or compound name, whatever it is, and you can just mention whatever licorice or citrus, whatever you want, and it takes you to the specific components that were already studied in literature. How many components there are, like, is there are 100 components in that literature, what those components, how they interact with different proteins, what are their interaction efficiencies. It's a very comprehensive presentation of a database of herbal compounds. So things should, like, I didn't see something like this in Indian perspective. I think things should go in this way. I think in future, like, people should come up with the herbal components already studied in India and try to validate it through herbal understanding. So the such base in this database, I'll try to just give it in a very brief extent. So it is the same way that I explained you previously in the case studies also. It's the compound information, target information, disease information. Depending upon that, they see the component screening of a herb, component targets network, and target diseases network. This is how it works, and it's a comprehensive network analysis. So this is how the search strategy goes there. And I'll take you to a Nobel laureate. He is Arvid Carlson, sorry for that. He's a Nobel laureate in 2000, I think. He discovered dopamine, which I explained in my first slide in the CNS pharmacology. And his studies have played very important role in the Parkinson's disease. He mentions it in modern pharmacology. It is so clear that even if you have a fixed dose of a drug, the individuals respond very differently to one and the same dose. This is how the future of the medicine will be, actually. This is how the future of pharmacology will be, is individualized and personalized medicine for understanding pharmacogenomics of each person, what their eating habitats are, because food is the best medicine, physiological medicine that we take every day. And the food we take depends upon the drugs we interact. So this is how the things will go in future. Thank you for your patience listening, and thank you once again, sir, for your opportunity to me. And finally, I want to end with one quotation of my inspiration throughout my career. Many hardships, but I never left out because of three people mainly: physical, mental, and spiritual. I'll not go to the spiritual aspect. Sir Gopinath sir is more experienced than me in this. The physical aspect of is Abdul Kalam sir. there's a more inspiration, and he is an inspiration for all the Indians, like teachers and students all. Never stop fighting until you arrive at your distant place. That is the unique you. I'm trying my best to find unique me. I haven't attained till now. The uniqueness comes in your passion, patience, and perseverance. And you love what you are doing. If you take challenge, you should love the challenge also every day. That's how the uniqueness is. There you find yourself. And this comes up with having an aim in life, continuously acquire knowledge, work hard, and have perseverance to realize the great life. Thank you once again, all. Namaskar. Sir, you're muted. Sir, you're muted.
Dr. Easwar, thank you very much. And for excellent session. See, the parent is very happy when their child will become more than the parent. The recognition. Now, you remember in the old days, see the same commitment, same the glow in the faces. And I'm another request from you. I told you biopic. Explain about the starting journey to the till today.
Yes, sir. Sir,
Yes, continue this one biopic.
biopic. Sir,
Your journey of the study from the primary school to up to this level.
yes,
It is
sir.
a motivating for the.
Yeah, sure, sir. I will continue that. Yeah, excellent. Thanks for the opportunity. In childhood, people told me that I don't know how to study actually, because I never remembered, I never memorized things. I was a logical understanding. I think I need to say some spiritual aspects here, I think, which Gopinath sir may appreciate it. I never saw the things in a memorizing aspect, and the books and the writing and memorization is very difficult for me. And I used to give up, and that's why I never care about what my marks are, whether I'm a university topper or not. It doesn't matter to me, because I couldn't make up in that way. I cannot write long together. I cannot memorize together. That's how my childhood goes completely with questions, and I used to just be silent and just speaking to myself inside. I don't know whom I'm speaking with. But seeing everything I used to see. Things came up with maturity, comes with time, as Swami Shivananda Saraswati says, that the immature self will do mistakes, and mistakes are the key part of immature self. And if you do mistakes, you will rise, and you should realize that you are doing mistakes, and you should learn from your mistakes. And by the way, I'm quoting Swami Shivananda Saraswati because he's not a spiritual saint. He's an MD cardiology, actually. And he's an inspiration for people like us from the medical background. And if anyone who is interested needs to go to Swami Shivananda Saraswati, because whom I'm inspired during my childhood, during my bachelor's. So I gave an example. I know that there are a lot of people like that in medical fraternity in India who became to the spiritual aspects and understood how the real life is. But Shivananda Saraswati is one thing which came into my mind. Again, at a very important time after intermediate, I thought of, obviously, as at that time when we were studying, MBBS is the only important thing. Next is BDS, and next goes with engineering. That's how people use it to categorize it. There was no logic. It was all the interest. Like parents used to feel that whether my son is going or my daughter is going to engineering or MBBS. That's what the life was at the time. So my father was also very curious that whether I was going to MBBS or not, because he wanted me to be an MBBS. But fortunately, I missed it. It doesn't mean that I'm saying wrong. I bow my hands to all the doctors, especially during COVID season, who helped a lot. But my destiny is not that, I think. It's a lot more. In future, it might happen. And as I told, the quotation is before you, that I'm trying to strive my unique me. But I didn't become a doctor. I went into research. But in research also, I had a lot of different aspects, because I couldn't stay there much in my mind, because it doesn't make me sense of cutting animals and just studying the tissues, because the whole perception of animal is different than human being. So again, I started asking myself where I am going, what is the study, what is this? And that's how, as I explained in my presentations, it was the systems. It is all the system. It is all the mind-body medicine. It is all the precisionness of the drug. It is all the personalization of the drug. It is what the future is. And this is what driving me to make it in future. As I told, I'm trying to go to mind-body research labs, but my passion is research. I'm an ever researcher because the main important quality of a researcher is a logical interpretation. A researcher has to have a logical interpretation. If you don't have logic, you cannot become a researcher. So I have the perception, and with Guru's grace and with teacher's grace, I got the perception of logical understanding to understand the holistic aspects, and that would like me, I think, to take in mind-body research in future. I think here I'll stop it. If someone has any questions, if sir wants to add anything, I'm happy to share.
Regarding this one, your journey, how the study the B Pharm, M Pharm, and again PhD and PDF. A brief about the 5 to 10 minutes.
Yeah, sure. About my bachelor's, as I told, when I went to pharmacy, I just know that pharmacy is only drugs. Not more than that, I don't. It was all like general. We used to get MCET ranks. I think people try to connect with me now. I think if there are any students there, we rush out with our MCET marks and we take that rank card there and to see that where we fit up. That's how the psychology is there. So I also rushed up to see that where I'm fitting my my MCET rank. And I realized that I don't fit for BDS and MBBS. So I went to pharmacy. But pharmacy got fascinated me. It's not that I just went to pharmacy because I didn't get MBBS. After going that, I thought that this is my learning and this is what my future career is. So I took it as a positive aspect rather than feeling that, no, it's all wasting and I didn't get what I wanted. I never thought in that way. It's a learning. Human being has to learn every day. So when I went there, pharmaceutics, pharmacology, anatomy, physiology, the first year, second year, and third year passed, and we used it to just study. But it's all, to be very frank with people here, it's not complete logical interpretation, because the mind doesn't mature in that way of finding the unique you. So I use it to understand how the pharmaceutics, the basic concepts, which are the building blocks, that's very important. And telepathy and teachers like, I should say that Ramara sir, who was the principal at the time, and Gopinath sir, Uma Maheshwara sir, Nagaraj sir, and Prashanti madam, Lakshmi madam. There are many people who participated in this journey in my life. So I learned many concepts there. But after pharmacy, I ended up, my interest is not to study masters in IIT BHU. To be very frank, I got fascinated with Benares. I like Benares basing upon his history of how Benares is. So that fascinated me to go to Benares in the university. And fortunately, the Benares in the university is the mother of pharmacy, because it was Emil Schroff who first established pharmacy institution there. And coincidentally, my interest in Benares coincided with mother of pharmacy, and I felt, oh, this is really good. So I went there and I started my career in pharmacology, and Sairam sir entered my career. He was very tough person. People don't use it to like him, because tough teachers people don't like, because they're really to the core, and he's really to the core, but I liked him. If a teacher can inspire at least one student throughout their life, then the teacher's job is done. And that's how I feel in my future generation too. And he inspired me like Gopinath sir too. So I felt that I should do pharmacology with him. By the way, after doing my PhD, after a lot of, I'll explain that next thing. But anyways, coming back to my first point, fortunately, time made me to take to Dr. Madhu Dixit. It was not my effort, it was all the destination. But the destiny comes with your interest also. You have a strong perseverance of learning. It's only you cannot believe the destiny. So I have the perseverance in heart. So time took me to Dr. Madhu Dixit, who is very tough person once again. She was a director of CDRA at the time, and she used to manage the whole institute. All my teachers are tough, and the toughness gave me to learn a lot and to constantly pursue where I am learning. And all teachers are experienced. That's how their experiences mattered a lot, because Dr. Madhu Dixit, as I told, is former director. And that's where I understood the systems, and that's where I felt where my destiny is. And my first postdoc is with Dr. Shailendra Patel. He's a clinician, by the way, here. MD PhD, not MD PhD, but he's a clinician scientist. He's a very experienced person. He's the division chair of endocrinology, a very tough person once again to manage, but it is a constant perseverance once again that helped me. And I bow to all my teachers in career, because if you are unable to manage your teacher, don't feel bad. You will learn a lot. Their experience matters you a lot. And now my next mentor is, the current mentor is Dr. Diptankar D. Mazumdar. He's from Johns Hopkins, and Johns Hopkins has a lot of reputation in research. And he's also a clinician. He's a cardiologist. He's a trained cardiologist from Hopkins, and he's a cardiac surgeon. And his MD PhD is interested in research too. So that's where I entered the lab. A very tough person to manage once again, but really happy because of constant perseverance.
And
I think passion, perseverance, and patience. If you lose any of these characters, you can never be there. You may have tough times. You may give up. You may give up in your mind. You may exhausted, but take a break. I took a lot of breaks in my mind. Make lifestyle changes. As sir teach about yoga and all those things. I'm also in that path. I'm learning professional yoga from Swami Vidyanandaji of Integral Yoga of Aravindo Ashram at Pondicherry now. Training for professional yoga teacher. Take a break, no problem. Take a lot of break. If you want, take a break of at least a month or something, or days. It depends upon your individual trait. But don't give up. That's where your passion lies. That's where your uniqueness lies. With this, I'll surely stop. And I think I'm not matured enough to speak more. And I think the career should speak.
thank you. The excellent words for the forthcoming generations, Dr. Iswar. Any questions, please? My co-faculty members.
Yeah, if someone doesn't ask, please feel free to reach me, and my LinkedIn will be having an account. And I'm every time with sir. So if someone is really interested to pursue something, we are happy to help being in state. So feel free to reach us. That's okay. Thank you.
Any questions, please? Thank you so much. And 1 minute. If there are no questions, my dear co-faculty members, you were given the unmute option. Madam, Uma Madam. Madam Chinna Devi Madam. Madam, be unmute yourself, Madam.
Sir, no, sir. Thank you, sir. But the sessions are very excellent, sir.
No. You'll see that one is the pharmacy always saying that one. After there are no medicines, we are coming in the last chance. But see that today the example of the resource persons, like
Yes, sir.
they reach from the bottom level to that.
Yes, sir. Yes.
In the similar way, you have to motivate our students wherever you
Yes,
are
sir.
working tomorrow.
Sure, sir. Sure, sir. Thank you, sir.
Someone is asking a question, sir. Actually, any opportunities for PDF purchasing, sir, for Indian PDFs?
Any questions, please? Any opportunities for PDF pursuing, sir? Indian PDFs.
Yeah,
There is a
in
question,
India's,
Dr. Iswar.
yeah, in India also actually there are PDFs. Like if someone is interested in CSR institutes, there are different fellowships there. I don't remember exactly the fellowships are, but in Indian perception also there are PDFs if people are really interested to learn. In relation with the international PDFs, there are opportunities too, but international perception goes in a different way. If someone is really interested, I think it would be better that they but opportunities are everywhere. If they wanted to constantly pursue, we'll get opportunities. It's always there. But in international perspective, at least with United States, it goes in a different way. It needs a lot of recommendation letters because people try to see how your perception is before taking at least interview, how good you are in your research and those things. If someone is really interested, they can reach me, reach any of the persons like my colleagues of other colleagues, Prahlad and people like from Ramakrishna. They all also give. So they can also reach. Prahlad is also working in Harvard actually. He can also help. I can also help in future. Welcome. Yes, there are opportunities. Sure.
Okay. And if there are no questions, we'll give the vote of thanks. And may God bless you. May God bless you, Dr. Iswar and Madam and children's.
Thank you, sir. Actually, sir, someone is asking me a question once again. Can you suggest some universities or any organization in India offering PDF? With that, actually, take central universities, especially with it's not academic universities have some fellowships, but I'm not sure. But coming from a background of IIT surely have some fellowships, and coming from a background of CSR family also should have fellowships. So go to CSR, Central of Council of Industrial Research. There are a number of labs there. Like CDRI is one example if someone is interested to be. So yeah, more than this, if you ask me specific fellowship, I'm sorry, I might not be now. I cannot say because it's not coming at top of my mind. But I can say you the universities, as I mentioned, central universities, IITs, IISc. If anyone is really interested, IISc might be one good opportunity. But I think people who are not having, I should say this, people should not, who doesn't have good papers in a core lab, they should see some fellowship where they can volunteer in a lab, they can learn things and they can go to that lab. They can work as a researcher in the lab and publish papers, because volunteer makes you to learn what the lab culture is, how the things are going in the lab. That's very important. At least with United States, volunteering is very, very important, and people do volunteer here.
Okay. Thank you. If no more questions, what are essential one must have after PhD to go to for PDF? Another question.
Very good question. You're taking me, I think, Uma Madam, I think she's taking me into the course of how the logics work here in PDF. Good question, ma'am. Actually, what happens is for a PDF, to be very realistic, papers are very important. So that's how the institution should develop and understanding of I know that so I'm speaking this, teachers should be competent enough in and learn things to make the students work for small UGC sponsored projects, where I think JNTU, I think, I don't know whether it has some before or not. If not, they can take up this one, because UGC sponsored projects will give an opportunity for you to go into the research, at least have some basic publications. If you have basic publications, you can go to PDF. Recommendations are one thing, but with recommendations, it should not work in that way, as I don't like. Recommendation should be secondary, but your CV should speak first what your skills are. Papers are the currency, and CV is the final output of your paper. That's it. Thank you, ma'am. Namaskar.
Thank you. And the any questions further? Any more, please? Unmute yourself, Yamini.
It gives me an immense
What is
pleasure to deliver the vote of thanks for this session. I would like to thank to our special guest, Dr. K. Somanageshwar sir, Dr. Babu Nageshwara Garu sir, for this session. Sir, in this session has been explained, started this session with his how he has entered into the pharmacy and how he got interested, and with the help of the faculty members, how he built his career and supporters, he has explained and started the session. And coming to the session, sir has started with the systemic pharmacology. He has explained. So what is meant by systemic pharmacology? And then he has explained the differences between the common scientific work and the systemic biological difference he has explained. And then what is the systemic pharmacology, sir has been explained. So what are the primary targets and other targets? So combining of these, how the therapeutic effect will be there. Along with the therapeutic effect, there will be a side effects which sir has been explained. And then coming to then sir has explained about advantages, how what are the preclinical and clinical network modeling, this and all sir has been explained. And then areas systemic of an ADME parameters, what are the models, elementary models, decision models, expertise models, cross validation and systemic decision, this was all explained. And then later on the targeted identification approaches like systemic pre-binding, then systemic binding and all explained. Design processing of the drug combination prediction approaches sir has been explained. And taking off an examples of the case studies, with three case studies sir has been explained how the targets we are going to be identified with the different pictures he has explained. And later on the database scheme has explained. And last but not the least, sir has tell about the what are the research person should have a knowledge. If there is a logic means that if a person want to be a research means, sir has told that there should be a logic in that research person. Thank you, sir, for your valuable information and advanced technology has been explained. We are very impressed for your speech, sir. Thank you, sir, for giving me this kind opportunity.
Thank you, Yamini garu, once again for the vote of thanks.
Thank you.
And thank you very much,
Sir,
Dr. Iswar.
thank
Thank
you,
you.
sir. Thank you, sir. Namaskar.
All the best. May God bless you.
Thank you, sir. Namaskar. Namaskar.
Convey the best regard to children.
Thank you, sir.
Thank you. And regarding the tomorrow sessions, the same tomorrow also you have to come by 9:30. Again from the ES. All my faculty co-faculty members. May I end up the session, please?